Alright, so for each inequality graph, pick a point and use it to determine which half plane should be shaded, then shade the correct half plane. So on these graphs, you can see that they've already graphed the equation of the line if this were an equal to, but since it's not, since it's less than or equal to or greater than or equal to, we have to actually shade as part of our answer. So this is one approach you can use to help you figure out if you should shade above or below a given line. So for each of these, we're going to pick a point, any point we want on the coordinate plane. But my hint to you is to pick a point that's easy to actually plug into your equation. And so for each of these in this particular page of notes, I'm going to use the point 0, 0, because that makes my life pretty easy. So we're going to do our work here to the side. So we're using the equation you see there, y less than or equal to 1/5 x minus 4. But instead of y, we're going to plug in a 0. And instead of x, we're going to plug in a 0 again, because this represents where x and y are 0 on the coordinate plane. And if we were to simplify this, well, 1/5 times 0 simply becomes 0, and we still have that minus 4, and then 0 minus 4 is just negative 4. So this is the part that you actually just kind of have to have a good understanding of your inequalities for. Is 0 less than or equal to negative 4? And when you're thinking through this problem, if you're getting stuck or you're not sure, I always just envision a number line, right? So on our number line, we like to draw 0 in the middle out of habit. Doesn't really have to go there. But negative 1, negative 2, negative 3, negative 4 would go here. So this particular thing is saying 0 is less than or to the left of negative 4 on the number line. And as you can see up here, that's not the case. 0 is greater than or to the right of negative 4. So this actually is not true, okay? And when that's the case, when we plug in a point, we do not want to shade the region that point's in. So right now, that region lies above my line of 1/5 x minus 4. You can see here it starts at negative 4 and then goes up 1, right 5. That doesn't give me a true statement, so I'm not going to include this point or anything else in this region as part of my solution. So this means we're actually going to shade below the line because that's where the true solutions must lie. Okay, so again, we plugged in a point, got a false statement, so we can't include that point in the solution or that entire region. Thus, it's the other region that contains your solutions. Okay, let's try number 2. Again, I'm going to be lazy and I'm going to pick the point 0, 0, but in reality, we could pick any point we like, any xy pair. Just make sure we plug them in the correct place and we're good to go. So again, here we're going to plug it in for y and for x, okay, but I'm going to write it off to the side. So 0 is greater than or equal to negative 3 times 0 plus 5. Okay, if we simplify the right side, negative 3 times 0 is just 0, and then we have that plus 5. And so now we're asking ourselves, is 5 to the right of 0? Let's see, 1, 2, 3, 4, 5. All right, so is 0 greater than or equal to 5? And as you can see, 5 is what is to the right of 0, not vice versa. Okay, so since 0 is not greater than or equal to 5, this is not true. Thus it is again false, which means we're not shading the side with 0, 0, but instead we are shading in the other side. That is where our solutions must fall. Okay. And in theory, all of this would be shaded in completely. I'm just being a little lazy right here, okay? Okay, let's try it on number 3. if I were to try a 0, 0 here. Now notice this one is a little bit different. So if we look at these first two, these are what we call in slope-intercept form, where y is by itself. And these are kind of nice because let's say we didn't want to deal with the algebra here. If you have a less than or equal to, that means, if you remember from yesterday, we shade below, which you can see we did end up doing here. We shaded below. And then if we have y is greater than or equal to, yesterday we said that meant we shade above. And sometimes it's kind of hard to tell, but this is technically above our line, negative 3x plus 5. So when you have the y by itself, you really have options. You can just go off of the sign, or you can actually plug in a point. But when we get to standard form, our options aren't as great. So we can still do what we did yesterday, which is sit here and say, okay, 5x minus 2y less than or equal to 10, and try to get y by itself. So subtract 5x over, and we can't combine those on the right, so they stay separate, and then divide everything by negative 2. But then you have to remember, oh, that means I flipped the sign. Then we have to simplify this, and negative divided by negative is a positive. 10 divided by negative 2 is negative 5. So that's still a good amount of algebra, and then that sign here of greater than or equal to, in theory, is making me think we are going to end up shading up here, but we're going to try our test point method to check it out. So we plugged in 0, 0, so we're going to have 5 times 0 minus 2 times 0, is that less than or equal to 10? So, well, that's pretty easy to figure out. That's just 0 minus 0, which again is just 0. So is 0 less than or equal to 10? Yes. This is true. And when it's true, that means we shade the region 0, 0 is included in, because he was a solution, so therefore everyone else on that side of the line also would work. All right, over here, let's try plugging in. Our test point is 0, 0. So we would have 3 times 0 plus 4 times 0 greater than or equal to 24. Again, this is why we like 0, because that's pretty easy to figure out. And then, is 0 greater than or equal to 24? No. No, it is not. So that's false. So we do not need to include that as part of the solution. We need to include the other side. So this is just another way to do what we were practicing yesterday, that I think for some of you might be easier than trying to do the more algebraic approach of solving for the y and then interpreting this inequality sign here, but both work. Okay, so on the next page, we're going to actually start with the answer and work backwards. So given the graph of the regions that are shaded, write the inequality or system of inequalities. Okay, so we are going to have to remember our good old y equals mx plus b here, where m is our slope, or rise over run, and b is our y-intercept, or start number, on the y-axis. So actually, let's start with our start numbers, because I think they're the nicest up front. So here we have a start number on the y-axis at what looks like to be a 7. Okay, and then we have to figure out the slope from here. So that would be down 1, here's a point, down 1, right 1, negative 1 and 1. So we have a slope of down 1, right 1, which simplifies to negative 1. We have a b of 7. So for our y equals mx plus b, we're going to get y equals negative 1x plus 7. All right, on number 6, again, let's start on the y-axis for the y-intercept. This one looks like it's at -4, and then we're going to end up going to the next corner it crosses through, so be careful about picking it. It looks like around here is the next perfect cross through, so that would be up 2 over 1. So our rise over run is 2 over 1, which just simplifies to 2. And our start number was -4. So then for our equation, we're going to get y equals 2x minus 4. Now, in reality here, I've already made a very common mistake, and I don't know if you've noticed this, but these equations we just wrote are the line. We just wrote this line, and we just wrote this line. But as you can see, these aren't just regular graphs. They've got all the shading that goes with it. Okay, so this is part of what makes it different than just a regular line. So what we're going to go do now is we're going to change our signs, because it's not just the values that are equal to this line. It also includes shading that falls below it. And because of that, we're going to say it's whenever y is equal to or less than this line. And when we come over here, yes, it still includes the ones that are exactly equal to this line, but it also includes the region that falls above the line. And so because of that, we're going to switch this sign to a greater than or equal to. So it's okay if you start writing it like a regular equation. You kind of have to think of it that way. But then your final answer has to have an inequality if there's shaded regions or shaded planes. Okay, so let's take a look at the last one. All right, so again, we're going to start with the y-axis here. This one is crossing at 10. And this one, it looks like we've had a negative slope here, a positive slope here. This one looks positive, but I can't really go up and right. So we're going to kind of have to work backwards. So it looks like we're going to have to go down 2, which is negative, and left 1, which is also negative. So we're going to have a slope of down 2 and left 1, which actually is just 2. And then we're also going to have a start of 10. So again, I'm going to start out writing this like a regular equation, 2x plus 10. But I'm going to go back here and I'm going to switch this from just a plain equals, right? It is still the line itself, so it has an equal part because it's a solid line, it's not dashed. But then it also has shading below the line. And I know it kind of looks more like left and right, but if I were to put my pencil here and drag up, that's not shaded. If I were to put my pencil here and drag down, that is shaded. So this will be, for all y values, less than or equal to 2x plus 10. And this concludes our video notes on linear inequalities.